it going? All right, so today we're going to look at ellipses. This is the third conic that we're going to talk about. Now, in the notes here, it says we're going to do a review of parabolas. I'm actually not going to do that here on the video, but we did finish out all of the parabolas homework worksheet. Let's just jump into ellipses. All right, so by definition, an ellipse is a set of points in a plane whose, this is a little bit different than yesterday, whose sum of the distances from P to the two fixed points. Remember that yesterday the fixed point was called the focus, but there's two of them, and the plural of focus is foci. Not foci, it's foci. And that sum to the two foci is always constant. Now, we did a little thing in class to help make this make sense. I'm just going to pick and kind of just summarize it here for us. Let's say that you have some point, and let's say it's right here. And I don't know that you need to draw this. Let's just watch for a second. If you measure from here, and then you measure over to here, those are your two foci. This is if you measure that, let's say it adds up to 80. Okay, so 80 is this number that it doesn't matter if I could find another point somewhere, let's say it's right here. And if I measured from here and measured to there, then that would add up to 80 also. Maybe I had another point here. Measured from there to there, it adds up to 80. And if I find all the points that will do that and add up to 80, what I end up with is an ellipse. And it looks like this. So this you can actually put out there because we're going to want to draw this and put stuff on it. So here's my ellipse. And all the points on that ellipse are the ones that when I measured from here and to there, it adds up to 80. Now, of course, I'm just making up the number 80 just because it's an easy number to work with. But whatever that sum is, it always stays constant. All right, now this slide has all the different vocabulary that we need to know about an ellipse. So right here, let's make note of all the things. And if you were into color coding in your notes, now's your chance. This is what you want to do. Okay, because there's a lot of info here. So here are your two foci that we had started with. And then this was some random point. Remember, this plus this added up to something we said 80. Okay, now here's the thing that if you think about this, well, let me come back to that. So when you create this ellipse, this longer distance right here, that's called your major axis. And the other direction, the shorter direction, is going to be called the minor axis. Now, a lot of times we only deal with half of the major axis or minor. So like this would be called your semi-major, semi-minor. The foci will always fall on your major axis, and your major axis is the longest one. Foci fall on it, and then where it hits the edge of the ellipse, those are called vertices. Have I covered it all? I think I did. Now, the equation of ellipse looks like this, and it looks a little bit scary, a lot of fraction stuff going on, a lot of squares, but to be honest, it's crazy easy to graph this. If you remember from the circles, that when you see this notation right here and this notation, you're in parentheses, so you're always going to do the opposite. So when I see an x minus h, this is really going to shift me left and right, and I'm going to do the opposite of what that says. Y minus k. All right, k is going to shift me up and down, and I'm going to do the opposite because I'm in the parentheses there. Now, this ultimately is going to be the center of your ellipse, just like it is in the circle. Now, where it gets trickier, or just different, I guess, than the circles are, is that it's longer one way than it is the other. So A and B, which are your denominators here, are called the semi-major and semi-minor axes. So notice that A is squared here. So if this was like 49, then A would be 7. And that would tell me that the semi-major or minor axis would be 7. To know if it's the major or the minor really just has to do with which one's bigger. Whichever one is bigger is going to be the major. So I have a couple slides that are somewhat filled out and some just kind of going through so it all kind of starts to make sense. Okay, I'm starting off an easy one. If you'll look at your numerators here, this is where you see what the center is. There is no minus h or minus k. This is the easy version because your center is at the origin when it looks like that. You can see in the graph that's already done for us, yep, it's centered right here at the origin. And then from the center, and this is us trying to graph this ellipse, whatever is underneath the x-axis is what I'm going to want to move left and, or the x, sorry, underneath the x is what I'm going to want to move left and right. Whatever's under the y, I want to move up and down. Now remember that this is an a squared, so I would square root it. So I'm going to go left and right 6. And you can see that's what's happened here. I've gone left and right 6. I'm going to go up and down 4. Up 4, down 4. And ultimately what we end up doing is plotting those 4 points. Kind of like what we did in a circle, except that we go left, right, up, down, all the same amount. So we're going to plot those 4 points, and then we're going to be able to just draw that ellipse in there. So from the center, go left and right 6, go up and down 4, and your equation, if you'll notice here, will always equal 1. In that previous slide, I didn't really draw attention to that, but it always is equal to 1. Here's an example of an ellipse that is more elongated up and down. So let's see if we can find all the parts. So looking here for your center, so you do the opposite. I'm going to go left 2, up 1. So that's a center of -2, 1. So left 2, up 1 right here. That makes sense. Got it. Okay. From the center, I'm going to go left and right, whatever the square root of that number is. And then I'm going to go up and down, whatever the square root of this number. So that means left and right 2, up and down 5. If you look at our graph, yep, left and right 2, up and down 5. And then we draw the ellipse from there, from those 4 points. And again, equation always going to be equal to 1. All right, so let's talk a little bit more about those foci. So the foci aren't going to help me graph this thing, but they give me information about the ellipse. And they might help me to be able to write the equation of an ellipse. Now, your foci will always fall, I said this earlier, will always fall on your major axis. So the major axis is the longest, so this makes sense here. Here's my longer axis, major axis, and here are the 2 foci that fall on it. Now I'm going to do some drawing on this, and I don't know how much of it you need to draw or just pay attention to kind of understand where we're headed, because I'm going to make it look pretty cluttery probably. All right, so here's the deal. So here's a point on the ellipse. If I measure from here to here, what's it add up to? Okay, we made up 80. All right, so we're going to stick with it. So it's 80. Could have been 20. I don't know. But every point on this, when I take this leg plus this leg, it's going to have to add up to 80. Now, I could do that all the way around the circle, but there's a few scenarios where it's extra special that what that means. So I'm going to get rid of the clutter, and let's look at just the ones that I'm talking about. So let's say you're looking at this point. When I measure to here and I measure to here, that's supposed to add up to 80. But because of the symmetry involved here, this would have to be 40, and this would also have to be 40. So those two would end up being the same. Okay, let's look at another scenario. Let's take our point that we're dealing with, and let's move it around over to here. Now, if I draw to this focus, and then I draw to the other focus, that also has to add up to 80. Those 2 segments add up to 80. And if you think about this for a second, well, and I did this with string. This right here is talking about the string. So I did this with string. So we had string that went from here and to here. Well, ultimately, I know that the string is going to add up to 80. But what if I grab this little double layered? See how it got overlapped here twice? So I'm going to grab this little piece. Wouldn't it fit in right here? So ultimately, if the string is 80, then from here to here would also equal 80. That's your major axis. Your major axis is 80. What is your semi-major axis? Just from here to here. Well, it would be half of that. It would be 40. And so that right there is what we're shooting for, is that you understand that this measurement here, the semi-major axis, would be 40 in this case, will always be equal to this distance here that goes from this point and really creates this nice right triangle. It creates what we'd call the hypotenuse of this right triangle happening here. Those measurements will always be the same. They're not always 40, they are always the same though. All right, so here's the kind of the slide that shows that. So we're going to look at this, and the distance, the semi-major that goes all the way to the edge, is called A. We label the semi-major axis A. It's how much we go left and right. Could be up and down, but let's just focus on the horizontal one for right now. And that A measurement is the same as if I were to draw in this right triangle. It'd be the same as the hypotenuse. A and B end up being your semi-major and semi-minor axis. Okay, A is the semi-major, B is the semi-minor. And C is always going to be the distance to the focus. So you can see right here when I drew the right triangle, I'm not drawing clear to the edge. I stop and make that smaller triangle. I stop right here. Okay. C, that distance is always called C, that distance to the focus. I remember it just because focus has a C in it. So that's my trick to remembering. Oh, when they ask me for C, that's the distance to the focus. Okay, one more thing before we jump in and look at some examples, but we have something called the eccentricity. And so I told you that the foci kind of tell you something about the ellipse. The eccentricity is what we're looking at. Eccentricity is defined as C over A. So remember, C is the distance to the focus. So that would be this distance to the focus right here. That's your C. And A is your semi-major axis, or it's the hypotenuse of the right triangle we drew. Those are both A. But ultimately, they think of it as the semi-major. So what we're comparing here is how far out is that focus versus all the way to the edge. So the farther out that focus gets and closer to the vertex, the longer and skinnier this ellipse becomes. And the most that C could ever be, well, I guess the farthest out it could go is as it gets closer and closer. What if it landed right on top of that vertex there? Well, then C and A would be equal, and your C eccentricity would end up equaling 1. All right, now we probably wouldn't even have any we wouldn't have any ellipse at that stage, but I think it's worth noting that the biggest then that the eccentricity can ever be is a 1. The smallest would be when this focus comes in until both foci are doing this until they merge right here at the center. If they merge here at the center, then C is going to be equal to 0, and 0 over anything is 0. So that means the eccentricity would be a 0, and that's the lower limit on this. The smallest it can ever be is 0. So your eccentricity will always be between 0 and 1. 0 actually is going to make it, and I didn't really leave us a space to write this, but let's go ahead and do it. If it's 0, it's very circular. So much so that the eccentricity on a circle is 0. It doesn't have 2 foci, it has 1 because those foci have merged to the center. So if a circle has an eccentricity of 0, and the closer the ellipse eccentricity gets to 0, then the rounder and rounder your ellipse is. The closer your eccentricity gets to 1 is the more flat and skinny. I guess I'm going to call it that, flat and skinny. Or just flat. Is flat sufficient? I'm going to write flat. You write skinny if you want, but it makes it really narrow, I guess would be a good word. And because, so I don't forget to do this later, because you will have to start finding eccentricity on circles and parabolas. So I just told you the eccentricity on a circle is 0, and the eccentricity on a parabola actually is always equal to 1. But the ellipses, it's going to vary depending on how circular the ellipse is. All right, so now I'm ready to jump in and let's do all the stuff. All right, so I'm going to start with this graph. I've given you the equation for it. Let's see if we can do all the things we need to be able to graph this. So first of all, it's the center. Can you look at that and figure out what the center should be? You're looking at your numerators. Looks like we need to go left 6. We need to go up 7. So that's going to be a negative 6, 7. I'll go ahead and plot that over here. And I just pulled this one corner of a graph out so that I can make this a little bit bigger. And so the origin is still here. All right, so looking at this, do you feel like this is going to be long, elongated sideways, or is it going to be a tall ellipse? Well, to answer that question, you look at your denominators. Whichever one is the longest is going to be your major axis. So my x-axis is longer. So my a is actually 3 because this is squared. So that means I'm going to go left and right 3. Okay, so I'm going to circle long because the x is bigger. I'm going to go side to side 3. How much do you want to go up and down? We should be going 2, square root of 4. All right, so let's go ahead and draw that. Left and right 3, up and down 2. And we'll go ahead and draw this ellipse. The next thing they want us to do here is find the vertices. Okay, so the vertices are where the major axis hits the ellipse, and the major axis is side to side. So this, oops, not what I wanted. This one right here is a vertex, and this one right here is a vertex. So I would write my vertices are, what is that, negative 9, 7, and 3, 7. Your foci are inside of this ellipse somewhere. Now, I don't really know where they're at, so I want to be careful about making any assumptions. So I purposefully stick the foci in here at a non-grid point because I don't want to accidentally think I knew what I was doing there. I'm just putting them in somewhere along the major axis. To find the coordinates of those foci, we're going to draw that triangle. So remember, you're always going to draw that smaller triangle. So when I'm coming this way, I want to stop when I get to the focus. Don't go clear to the end. So that's one value. And then we're going to go up and then down to here. That right triangle, I sometimes like to redraw it on the side where it's bigger so that I can see my numbers better because it gets tiny on these little graphs. So I randomly chose those foci. So I'm going to put an X right underneath on this bottom leg because I don't know what that length really is. But I do know that I went up 2 right there. And I know that I went left and right 3. Now that's my A, but do you remember that that A value is the same as this hypotenuse right here? So since I went left and right 3, I would put a 3 on my hypotenuse because I actually know that. And then I'm going to say, oh, look at that right triangle that I have. And I know 2 sides. I bet we can find the third. So I'm going to do 2 squared plus x squared equals 3 squared. Now, I am purposefully not putting in a squared plus b squared equals c squared because the a, b, and c, remember how they represent the semi-major, the semi-minor, the distance to the focus. And so I don't want to get confused on my a, b's, and c's. So I usually designate which side do I not know. I put an x on it, and that's what I use in my Pythagorean theorem. So this is going to be a 9 minus 4, square root both sides. So x is equal to a plus or minus root 5. Now let's think about what that means. what that tells us is that's how far from the center the focus is. And it's that direction, this, or that same amount this direction as well. But I'm supposed to write the coordinates of the foci. Well, that's pretty messy if this length is going to be a square root of 5. So here's how we write the foci. We really just base it off where the center is. And I already know the center. But from the center, I went left and right the square root of 34. Or I'm sorry, the square root of 5. And that's what I'm going to write for the coordinates for the foci. From the center, I went left and right that square root of 5 here. So instead of at -6, I'm going to write the foci to be -6 plus or minus root 5. And that's the x coordinate. The y coordinate for those really is the same. The vertices, the center, the foci, everything falls on that same horizontal grid line at 7. All right, the last thing I have here is the eccentricity. And earlier we wrote that the eccentricity is always going to be C over A. So the distance to the focus, so in this case, the distance to the focus is this x value that I was looking for. That's that square root of 5. So I'd have square root of 5 versus the distance all the way to the edge, the semi-major, which was your A, which we found, or what we knew was a 3. So square root of 5 over 3, which as a decimal is about 0.74. So remember, the closer to 0, the rounder it is. The closer to 1, the more elongated it is. And this one's kind of elongated. So that's what a 0.74 eccentricity would look like. All right, so we did that one kind of long. It took us a while. Did it pretty slow. Let's pick up the pace, see if we can do another one a little bit faster. All right. Looking at the center right here. That's your numerator always. Just like in the circle, I'm going to go left 1, down 4. That's going to get me a center of -1, -4. Let's go ahead and plot -1, -4. Now, when I look at it and I try to decide, is this a long ellipse or a tall ellipse? Now I'm looking at my denominators and I'm looking at which one's bigger. Oh, the one underneath the y is. So this is going to end up tall because I'm going to be going side to side 2, but I'm going to be going up and down 5. Just square rooting those. So this is going to be a tall one, side to side 2, up and down 5. And I just get my 4 points in there. So up and down 5, left and right 2. And let's draw a nice ellipse. They're not pointy, keep them round. Looks like this. And then I want the coordinates for the vertices. The vertices are where the major axis hits. So last time that was horizontal, but because this is a tall ellipse, this is your major axis. And so these are your vertices. So I'm going to put one vertex is at -1, 1, and the other vertex is at -1, -9. Now, the tricky part, the foci. This is where you have to draw in the little right triangle. But first, I want to go ahead and get the foci plotted randomly in here. So I'm going to say I'm going to put it right here, and then just to keep it all symmetrical, put this one here, and I want to find the coordinates of those foci. So I'm going to draw the right triangle. I always draw the smaller distance. Stop when you get to that focus right there. Don't go all the way to the corner. And then this side, you do go to the edge. And here's our right triangle. I'm going to redraw it out here a little bit bigger. So do you remember which one of those things do we not really know that we sort of made up? Well, I made up where to put this focus. So I know that this distance right here is not really known. That's my x. That's the distance to the focus I'm looking for. I did really go left and right too. So I know that this measurement is 2 right here. And I knew that I went up and down 5. So recall that this longer distance, this semi-major right here, that's 5 units, is the same as the hypotenuse in that right triangle. So that means that's a 5 right there. And then I'm going to do a little Pythagorean theorem. X squared plus 2 squared equals 5 squared. So that's a 25 minus a 4. X is going to be the square root of 21. So what that means is that I am going up and down the square root of 21 from the center. So when I write the foci, I'm writing it based off this center point. Now, remember, I'm going up and down, so this time it's going to affect the y value, not the x. The x's all are -1. So it's a -1, comma, and then I work with the y. I start at the center, which is at a -4, and I'm going to add or subtract the square root of 21. Now let's go ahead and find our eccentricity on this. So the eccentricity is the C over the A. C is the distance to the focus, which was our X. In this case, we were looking for that, square root of 21, over A. So distance to the focus versus all the way to the end. You're comparing how close those two are. And all the way to the end was the 5. So square root of 21, if I type that in here real quick, square root of 21, and divide it by 5, this is a 0.91, 0.92. Okay, so you can see it's a little bit skinnier than the last one was. And so this is getting closer to a 1 as we do that. I'm going to look at a problem and go the other direction. What if you already have the equation? Or what if you already have the graph and you want the equation? All right, let's see. I can give you all sorts of information. And I'm going to give you the right information to where you should be able to write the equation of the ellipse. Okay, so I'm looking at this one. I feel like this first one is just centered right here at the origin. That's going to make the the numerators of my fractions really nice. And I am a firm believer that you do not leave these blank. You can find almost the entire equation just from a little sketch of the graph. The center is an easy one. X squared plus y squared. I know that it will always equal 1. Okay, so then I'm going to look at this and say, what did I go left and right? Looks like I went left and right 3. So the semi-major axis is 3. That's my A value, and I'm going to put a 9 then underneath my x squared. How much did we go up and down from the center? We went up 1, down 1. So 1 squared is still 1. I'll go ahead and write the 1 so that you can see that that would be the denominator. There's our equation. Simple as that. Let's try another one here. Let's make it a little harder. So this one says that I have vertices at 3, 6, and 3, -2. Those are the vertices. Those are the edges of the ellipse. Because the foci are at 3, 5. Let me change colors here. Here's my foci. And at 3, -1, right there. So those foci are really, really close to the vertices, which means this is going to be a tall, skinny ellipse. All right, so I don't really know how far to go left and right to draw it, so I guess I'm just going to sort of freehand it. Oops, I'm going to change that back to a blue. Freehand my ellipse, and then the foci are somewhere in between there. So let's see, let's just jump in and let's start. I don't think we're centered at the origin, but the center is really the center of everything. So I feel like we can eyeball that center value to be right here. Okay, so that coordinate is 3, 2. So if the center is at 3, 2, that means my numerator will be x minus 3 squared. And I don't know that I've said this, but it is always a plus sign here. Never do we put a minus sign there today. And then the next one is going to be a y minus 2 squared. And I know it always equals 1. So look at all that stuff I did. Now, I even think I know how much I went up and down. I truly went up and down because it told me the vertices. Let's count that. 1, 2, 3, 4. We went up and down 4. So underneath my y, I'm going to put a 16. Remember, what you do up and down goes underneath the y. What you do left and right goes with the x. However, I sort of just made this up on the sides, right? So that's why I kind of make these big points to help emphasize that I don't really know this. Don't make that assumption that's a 2 from the center. It's not. I just made it up. So I'm going to go ahead and draw in my right triangle. Draw the smaller right triangle. It goes up to the focus and stops. It will go all the way to the side here, but that's made up. That's my x. And then this is right here. Okay, so to the focus, it looks like that length is 3. To the vertex is 4, and I put that 4 measurement on the hypotenuse. All right, here's just a little bit bigger diagram of that. 4 on the hypotenuse, 3 on this leg. I don't know how much to go left and right. But I can do Pythagorean theorem to find it. So here I go. X squared plus 3 squared equals 16. Well, sorry, I should just write. I don't care if you write 16 or if you write 4 squared. Either way. All right, so it's a 16 minus 9. So x squared is 7, so x is the square root of 7. Interesting. All right, so that's how much I'm going left and right. That x value is, that's what that's telling me. So if I square the square root of 7, I'm going to just have a 7 right here for a denominator. And that is our equation. All right, we made it. Last problem. Again, we're going to write the equation. I'm going to give you something different here. See if we can work through this. The foci are at 0, 0. And at 4, 0. All right, so if the foci are going horizontal of one another, that means the major axis is going that way and the vertices are that way. And what else do they tell me? That the major axis has a length of 8 units. All right, well, the first thing I really probably need to do is figure out where my center is, and it would have to fall smack dab between the two foci or vertices or whatever. So the center point, I'll go ahead and write. Keep doing that, sorry. The center point is at 2, 1. So if I'm writing this equation, I know that it's going to be an x minus 2 squared plus y minus 1 squared over, those are over something, and equals something. Oops, I don't know why I put 1s there. Let me erase those off there. Whoa, that's a big eraser. Okay. Now, our job is to figure out what goes underneath there. So looking at my graph, I have the center, I have the foci, but it tells me that the major axis is 8 units. That's 8 units total. So what that's going to mean is that from the center, I'm going to have to go left and right 4. And that would add up to the 8 that I wanted. Now, I'm going to go ahead. I guess with that, I'm going to go ahead and draw my ellipse in here, but I'm sort of doing it randomly. Keep that in mind. It's sort of random right now. I knew that it was going to be longer than it was tall because the foci were falling horizontally. This right here is your major axis right through there. Now, I shouldn't have done that. I'm going to erase that off because what I want to do really now is draw my triangle, and I want to draw that triangle, and I just want to stop when I get to the focus. Don't keep that going. Now, this direction, I have nothing to stop me, so I'm going to keep on going up. And over here, I have a slant. Now, to write the equation, I got to know how much I went left and right and up and down. I think that I currently could figure out how much I went left and right because they told me about this major axis. From the center, how much did I go left and right? 4. And what's 4 squared? 16. And since I was going left and right, you're putting that underneath the x. And the whole trick is to get the y value figured out. So I'm going to redraw. I stop doing that, please. Okay. my right triangle. I do not know where those, I do know where those foci are. I know that I went left and right too. I do not know really how far I went up. I totally made that up, but I know all the way to the edge is 4, and that measurement is the same as my hypotenuse. So you end up with a 2 squared plus x squared equals 4 squared. So 16 minus 4, that's going to make x squared be 12. Now I can square root it if I want, but I really just turn around and square it when I put it back into the denominator. So it's going to be a 12. That's how much I went up and down from the center. All right, there you go. Hopefully that all makes sense. Go give it a shot. Good luck.